a piece of wire of resistance 9 ohm is drawn out so that its length is increased thrice its original length. Calculate the new resistance. So I have a wire. The resistance happens to be 90 ohm. And now what we're doing is we are the same wire itself. We are pulling it to a length of 3 times. So let us do that. Uh, 3 is 1, something like this, right? So 3, 4, 5. Yeah, it's correct. I think, yeah, this is good enough only. You guys can understand, is it not? So the length is increased by 3 times. What happens to the cross section? They won't be the same. What we have here is not right. We need to resize it. So it will become something like this. Okay, thin and long. Is it not? When you pull it, obviously it will become thin and long. Same way as a rubber band. Right? If you want to understand this, take a rubber band, pull it. Right? The rubber band also will show the same behavior. So now, how is that we are going to answer this the same way as we did the last question? Okay. So we'll begin by describing the dimension of the original length. And here the resistance value is actually given. And go about doing the same way of calculation. The answer will be 10 ohm. Sorry, not 10 ohm. It will be 810 ohm. It will be 9 times of this value. Because it's pulled thrice, so it will become 3 square. This is what I taught you guys in the last question, that the trick to do such questions. The square, since we are pulling it, the resistance will increase and it will increase by thrice. I mean 3 squares times. So it will happen, that happens to be 9. 9 nines are 81. So 810 ohm is your answer. But yes, you guys try the calculation, try to work out on a similar line and try to get that answer. So we will begin with, let the original wire's length be of L meter. Then area of cross section be of 3A meter square. Okay. And we have resistivity be equal to rho ohm meter. And the resistance happens to be 90 ohm. So all of this is given. Now, the wire, when pulled to thrice its original length, so we have the length L 3L, sorry, the length will be equal to 3L. Area of cross section be equal to 3A by 3. So this will become A meter square. Okay, so this is the only thing that will confuse many. So again, just take a rubber band, pull it, you will see the effect. So resistivity, what will happen to it? Resistivity is nothing will happen to it. It will remain to be the same because it's the same material. While the resistance is what we have to figure out. So R new by R old. Here too we have to take the ratio. It's equal to rho L new by A new. divided with rho L old by A old. So rearrange by A new into 1 by rho A old by L old. So rho gets cancelled and we have L new is 3L by A new is A. A naught is 3A. This is L, right? And now it's just a matter of cancellation. So this is equal to 9. So R new is equal to 9 times of R old. So we'll substitute, right? We need not write all of that. So therefore R new is equal to 9 times of 80, 90. So this will be equal to 810 ohm, right? And this is your answer. So it is 9 times that of the old resistance, and that happens to be 810 ohm. That's it. Okay. So I already told you guys what happens, and you need to understand the concept. So understanding the concept is this way itself, and practically you can take a rubber band and do it off. It's not that hard. You'll get from a thicker rubber band to a thinner rubber band, but longer. Right? So pause and have a look at the answer.